extreme natural hazards, risks, and societal implications in the Philippines, let us welcome the Undersecretary of the Department of Science and Technology and Officer in Charge of Philippine Institute of Volcanology and Seismology, Dr. Renato Solidum Jr. Sir?
Thank you. Thank you very much. Good afternoon.
Good afternoon, sir.
Okay. Can you see my screen now?
Yes, sir.
Okay, let me just put it in the presentation mode. Well, good afternoon. I think my topic is very relevant, related to the context of what we have this afternoon. I'm in Quezon City, and my backdrop is inclement weather, strong rain. But I will talk about certain hazards that we really should worry about. And these are the extreme natural hazards, their impacts, and its implication in our society in the Philippines. As we all know, the Philippines is prone to many natural hazards. These can be related to weather and climate events, the hydrometeorological hazards that would include strong wind, storm surges or high waves in the coastal area. Heavy rains can trigger floods and landslides. These are more frequent than the geophysical hazards. But geophysical hazards, when they do occur, can really devastate a wide area and cause physical damage to many structures. We are prone to many large earthquake events, volcanic eruptions, and even tsunami. However, we also need to prepare for a global problem, and that is climate change. Climate change has been occurring throughout Earth's history because of the natural variability of how the Earth would revolve around the sun, how the Earth would rotate around its axis, or its axis being tilted closer to the sun from time to time. There is also natural variation due to changes in the solar radiation, or the energy coming from the sun to the surface of the Earth. Coupled with that would be changes in the greenhouse gases that can actually trap the reflected or the re-radiated heat from the surface of the Earth back into space. However, sometimes greenhouse gases like carbon dioxide, methane, nitrous oxide would have more concentration during certain times or periods of our history. And that can occur, for example, during large-scale volcanism, meaning more volcanoes erupting and putting in carbon dioxide in the atmosphere, or since the 18th century, because we started to burn fossil fuels, then we saw the increase in greenhouse gases into our atmosphere. And these greenhouse gases essentially trap more of the radiated heat from the surface of the Earth, and less heat escapes back into space. And that is a real problem. And if you look at the evidence of changing climate using carbon dioxide in the atmosphere, and this can be measured by getting the concentration of trapped air inside ice cores, where the ice layers can be counted every year, then we can say that indeed, during, for example, the last 400,000 years, carbon dioxide as a proxy of the temperature of the Earth has changed. The higher carbon dioxide would mean warmer temperature, and the lower carbon dioxide would mean cooler temperature. So in the past 400,000 years, we can see at least 5 cycles of warming and cooling. And the last ice age, for example, was 20,000 years ago. If there is no contribution from man, we can expect that the carbon dioxide concentration in the atmosphere would be around 280 parts per million, or less than 300 parts per million. But starting 20,000 years ago, because of the natural variation, our Earth is into the global warming stage anyway. However, since the 1800s, fossil fuel burning has caused a dramatic rise in carbon dioxide. In the graph, it is around 375 parts per million, but this was long ago. And currently, based on measurement, our carbon dioxide in the atmosphere based in the Mauna Loa Observatory is around 420 parts per million. Indeed, man has caused the further increase of the temperature of the globe because of greenhouse gases. If we talk about life-threatening effects of the various natural processes that occur on Earth, and even the climate change effects, hazards vary in nature. It can vary in terms of scale or magnitude, from small to large. Some hazards have different onset, slow onset, sometimes very rapid. We can consider climate change as a creeping or slow onset and earthquakes as a rapid onset events. Hazards can occur as a single hazard, or it can occur simultaneously. For example, fire can just be one, or landslide, but landslides can happen during heavy rains, and this can be accompanied in some areas by flooding or by strong wind. And for earthquake, we can have many hazards like surface faulting, ground shaking, and many others. But ground shaking in large earthquake events can cause cascading hazards. Strong shaking can cause collapses of houses and buildings, can cause soft ground to liquefy, can cause steep slopes to slide, and can even cause fire. So when we talk about events like earthquakes or tropical cyclones, then we need to look into multiple and cascading hazards. The other important factor in hazards is that it causes different impacts. Different types of impacts. Some are physical. Some can be just by burying something, or areas getting wet like floods, or it can vary in terms of severity. And sometimes because of the scale of the hazard, then the duration of the disaster can be quite long because recovery is low. So when we want to prepare for these different hazards, we need to think of these various factors. Of course, I think we are ready for many hazard events, but perhaps in a smaller to moderate scale hazard. What we need to look into would be our preparedness and our risk reduction capacities in terms of extreme events. And these extreme events are either large magnitude events, like, for example, magnitude 8 earthquake or greater than magnitude 7 earthquake, or super typhoon like Yolanda, or perhaps events that will lead to disasters. So large scale or large magnitude hazards obviously would be less in frequency than other hazards, so the probability of its occurrence will be lower. But other hazards, even low, can lead to disasters, or even those frequently occurring hazards can lead to disasters depending on the exposure of the society, number of people, number of structures. So any hazard that can lead to damage which is significantly high can also be considered an extreme event. So I will focus on this extreme events. And to show you some of what has happened so far, I will cite some extreme events that have happened in the Philippines. For example, the 2009 tropical cyclone Ondoy, which dumped more than a month of rain in less than 1 day. And it affected 4.9 million people. It caused 464 dead, damages of around 11 billion. And in terms of the educational sector, it damaged more than 1,300 school buildings. And of course, the societal interruption that this tropical cyclone has caused would really affect other operations and businesses. For example, I myself was trapped at the Naiya airport for several hours, and I cannot go home for several days because the road leading to my house in Cainta, Rizal was flooded. So this is an example of an extreme event. Another extreme event would be the Super Typhoon Yolanda or Tropical Cyclone Kitsana in 2013, where we saw many houses and structures damaged due to strong wind, But most importantly, those near the coast were affected by storm surges, sometimes as high as 5 meters. A famous scene would be a ship pushed further inland. And this really affected 16 million people, at least 6,000 deaths, and more than 1,000 people missing, and really cost 95 billion pesos of damages. Really a lot. A smaller scale event, but of significant impact, would be the 2006 Ginsaogan landslide in southern Leyte. The landslide was caused by the intertropical convergence zone, where it triggered heavy rains for around 10 days, and a moderate or minor earthquake event, really causing the already saturated slope to fail. And close to 1,300 people died or assumed dead because they are still missing. And almost the whole village of Ginsaogan was buried in an instance. This is an example of an extreme event, which is a combination of both a rainfall and an earthquake. And this can be a preview of what can happen because of global warming as slopes become wet. And since the Philippines is an earthquake-prone country, then we expect more landslides to happen. So later on in my presentation, I will talk about extreme events that are projected because of climate change. In terms of other geophysical events, we take note of the 1976 magnitude 8.1 earthquake in the Moro Gulf in the Celebes Sea and the tsunami it caused. Magnitude 8.1 is really a very strong earthquake. It occurred past midnight with an intensity 7 or intensity 8 shaking. And this caused a tsunami as high as 9 meters, the first wave arriving 2 to 5 minutes after the main shock. And this flooded or inundated inland for around 2 kilometers. Around 8,000 people died, 90,000 people were rendered homeless. And back then, the damage would be around 400 million pesos. More recently, we had the magnitude 7.8 Luzon earthquake, which affected central Luzon, the Cordilleras, and even shook southern Tagalog. Around 1,280 people died. This injured around 2,700 people, and close to 100,000 houses were damaged. Come to think of it, if the epicenter of the earthquake, which was in Rizal, Nueva Ecija, an unpopulated area, would occur in an urbanized setting, then most likely the death and casualty and the damage would have been quite high. Almost a year after the event in 1990, Mount Pinatubo in central Luzon erupted. This was the third largest eruption in the 20th century. It exposed 1 million people to the effects of the eruption. Because of the appropriate warning and evacuation, around less than 300 people died because of the eruption, many from roof collapses. But because of the ensuing volcanic debris flows or lahars, a total of around 850 people died from the eruption and from the ensuing lahars. More than 100,000 houses were damaged, many of which were buried by lahars. And the effect of the Pinatubo eruption was quite felt all over the world, as the sulfur dioxide aerosol, which reached the stratospheric levels, blocked the rays of the sun and heated the stratosphere but cooled the lower part of the atmosphere. So we enjoyed a little bit of global cooling a year after the eruption. If we examine these extreme natural events and even smaller ones, we see various impacts and losses: life losses or injuries, diseases. We see physical damages to buildings, infrastructure, and other properties. And hence, this would interrupt public and other critical services, especially water, energy or electricity, communication, and transport systems can be damaged. In many of these disasters, there were interruption of food supply and would cause severe disruption of economic development in a city or town. But perhaps if we look at it for very extreme events, can affect the whole country. We see a lot of people displaced, and communities, social lives are disrupted. To give you a clearer and uh, very urgent situation that we have, we compare the Philippines among countries in the world in terms of exposure to hazards and the potential impacts or risk. On the right side of the column is the top 10 countries with the highest exposure to hazard. The Philippines is number 8, Japan is number 10. To the left would be the countries most exposed to risk, or those with the highest risk. The Philippines is number 9, Japan is out of the top 10. The conclusion that we could make in this graph is that, or this table is that disasters or future risks or impacts or future disasters is really controlled by all of us, by man. So I don't usually call hazards as natural disasters. I use the word natural hazards, but I don't use the phrase natural disasters, because disasters, if we are not affected, which would mean that we can control our fate or the impact of these hazards to us, is really man-made. So what we need to do is really understand what causes the high risk in extreme events. The risks to extreme events are influenced by the following. Even though we have more knowledge now in terms of science and the ability to look into the possible scenarios that can happen in the country, which of course we still would need to improve on, the risk can be influenced by the magnitude of the event and the associated hazards with it. Obviously, the lower scale hazards or the lower magnitude events would not cause a lot of hazards, or severity of hazards would not be that high. But even though science is improving, we still have a lot of problem in terms of the high exposure of communities to extreme events. Many are still living in dangerous places, or they have very high physical or social vulnerability to extreme events like flimsy houses, non-engineered houses, or old houses. And even people sometimes are not prepared to the large-scale extreme events. Shown on the lower part of the slide would be the three factors: the hazard, the exposure of a community to extreme events, like these are people, assets, physical assets, businesses, and the vulnerability, the susceptibility to the negative impact of these different hazards. Now note that even though the hazard would be extreme, but if you're not in the area that it will affect, you are safe. But even though you're exposed to the hazard, but you have the capacity, or for example, your house has the capacity to withstand the hazard like a strong earthquake, and you are prepared, then your vulnerability will be much less. So in this presentation, hazards, exposure, and vulnerability would intersect if they represented the circles, and that intersection will be the risk. Our goal is to reduce the area of risk, or reduce the risk, by not only anticipating the hazard, but more importantly, reducing the exposure and reducing the vulnerability, or on the other side, increasing the capacity to be less affected by these extreme events. To look at it in a process manner, I have coined the term disaster imagination. Albert Einstein said that imagination is more important than knowledge, meaning we have to look forward into the future so that we can really appreciate what we need to do. And so for me, the following steps are needed. We need to identify the hazards that a process would bring, which area or which region will be affected. In terms of the scale of the hazard, depending on the scale, there will be less areas affected for small-scale events and larger areas for bigger events. But more importantly, we need to look at the potential casualty, the social, physical, and economic losses. Why do we need to do that? Determining areas that hazards can affect with would be very important for early warning, so that people will have early action. And our goal there is to save lives. That would mean preparedness, and appropriate response during the event. But we also need to look into the potential losses so that we can propose appropriate countermeasures. And that would be the mitigation aspect of the disaster management cycle. Given all of this, then we can actually have a scenario of most likely the possible damage or impact, both within the locality and outside, so that we will have an idea of what has happened immediately after an event, so that we can prepare in advance a response plan and even a recovery plan even before the disaster would occur. That is very important. So the key to a very good risk management is to imagine by having the appropriate science and engineering-based scenarios. So let me go over some of examples of extreme events that we need to prepare for. We have around 300 volcanoes in the Philippines. 24 are considered active, meaning these have erupted in the last 10,000 years, or somebody has witnessed its eruption. Currently, we monitor 10 instrumentally because the others are not really either acting up or the exposure of a high number of people is very low. Okay. Among the volcanoes that we monitor, Pinatubo, Mayon, Canlaon, and Bulusan volcanoes are at alert level 1, meaning there is some unrest. No? But Taal volcano in Batangas, close to Manila, is at alert level number 3, meaning there is ongoing magmatic activity and eruption, although in a smaller scale. And to prepare for a volcanic eruption, we need to think of the key volcanic hazards that a typical volcano would show. Of course, people would imagine the flow of red hot lava coming down the crater of a volcano. That is not a very dangerous hazard, but can affect properties along its path. The typical hazard of volcanoes would be the rain of ash and rocks, or the ashfall event, and the rapid descent or outward movement of hot ashes and rocks, either down the slope of the volcano, we call that pyroclastic flow, or outward of a crater, and that is a base surge. And we call those pyroclastic density currents. And these are the hazards that we try to assess so that we can determine which areas need to be evacuated before the volcano would explode. After an eruption, and if loose deposits are on the slopes of the volcano, then these can be remobilized as lahars, which can further bury villages or towns further downslope of the volcano. Even if the volcano would not explode, but if it would emit a lot of gases, then it would also be dangerous to people's health. Now, if a volcano has a water around it, or if the volcano is near the coast or in an island in the ocean, then a collapse of the volcano or the deposition of the pyroclastic density current on the water body near the volcano can cause volcanic tsunami as the water gets displaced by the mass that would reach the water body. So last July 1, we raised the alert level of Taal volcano to alert level number 3 after around 4 months of high seismicity and emission of gases. And this is a typical example of a phreatomagmatic eruption where the explosion is due to the interaction of hot magma with water. And although you can see a vertical column, but since this is wet and heavy, it would readily collapse. And the collapse would cause some elutriation cloud to move down the slope of the volcano. This is not the really dangerous base surge that we need to prepare for Taal volcano, because base surges, aside from the vertical eruption column that you would see from Taal, sometimes there are horizontally projected blast of ashes and rocks that can cause it to move 60 kilometers per hour or greater. And that would be the real base surge that can threaten people's lives, even in the mainland, as the mass of ashes and rocks can travel above water. Now, this activity is followed by the present upwelling of gases. As you can see, the water in the lake is really steaming, and you can see the steam with the gas coming out of the crater and forming a steam cloud. Okay, and this current unrest might lead to several scenarios. And what will the scenario be? This can either be a minor gas eruption, uh, triggering phreatomagmatic or strombolian eruption. If it's a phreatomagmatic eruption, there can be base surges. Base surges are those on the right side, the phreatomagmatic eruption of 1966, where you can see a horizontally moving cloud away from the eruption center, and that would be very dangerous. But the scale is not so large, so we don't expect many people to be evacuated if that is simply the case of the eruption. If it's a strombolian eruption where there is lava fountaining, like a fireworks, we just expect lava flow and asphalt in the surrounding area. Lava flow is not that dangerous because it will be confined in the island only. If it's a small-scale event, it will lead to either cessation of the activity or might continue to erupt. But in essence, we don't expect the current activity of Taal to be a very large-scale activity because the magma that is involved at its current activity is degassed, and the explosivity of a volcano's eruption is dependent on how much gas is trapped within the magma. Nonetheless, we need to monitor if there is new magma coming from way, way below and supplying new and gas-rich magma beneath the crater of Taal. And of course, that must be monitored continuously. Now, would Taal behave like that? Well, in its history, for the past 500 years, there have been extreme events in Taal volcano which caused significant physical and, of course, demographic changes. Way back in 1754, there was a very large explosion that, a very large eruption that lasted for 7 months. So imagine you have a 7 months eruption, it will really interrupt many activities in the Taal Island, surrounding area, and even outside of Batangas. Even Metro Manila might be affected. The worst case activity for that eruption caused an eruption like Pinatubo, where the eruption cloud was around 40 kilometers high, and the ashes were drifted to the west and south of the volcano, but also moved towards the north and affected Metro Manila. And the base surge that was, or the base surges that were triggered by the very strong eruption affected the entire Taal volcano island and the surrounding areas, especially on the west and southwest. And what is a base surge? Again, base surge is a very fast-moving cloud of ashes and rocks. And the 1754 eruption actually moved upslope towards the slope of Tagaytay. Did not reach the Tagaytay Ridge, so we don't think Tagaytay Ridge is in danger for these term surges, but at least the middle slope was affected by the base surge. And this is now the deposit of the 1754 base surge. And for scale, you see a person there at the bottom of the base surge. It's quite thick. So base surges can kill people, one, by burying you, by asphyxiating you, or by burning you. So it's really important that people are out of the way. So as an extreme event, we need to look into what is the worst case scenario for a base surge from Taal volcano. Shown here is a base surge hazard map, assuming an eruption from the main crater. Why is the main crater eruption the worst case? Well, essentially it's in the center, and we think that since this is really unconfined, and most of the historical eruptions from the main crater were large, then this can be the worst case event, okay? And you can see in this map, the yellow areas are those colored, are those to be affected by the base surge. And further out, we have some yellowish areas. These are the buffer zone of at least a kilometer, where the clouds of coming out of the base earth deposits might still affect areas farther out and can still affect the breathing of people. So you can see that a big part of Batangas province is threatened by this. And towards Tagaytay, the slopes there can also be affected. Tagaytay City is not affected by the base earths because it's quite high, but around 300 to 400,000 people are threatened by a worst case eruption of Taal. So in the long term, we need to be looking into a hazard and risk sensitive development planning of the area. Aside from improving the evacuation procedure, improving the road network so that people can have access to speedy transport away from the volcano. But in the long term, we need to look into how these areas will be developed. Moving into another hazard like the earthquake, we all know that the Philippines is really prone to earthquakes. Shown on the left is a map of earthquake epicenters represented as red dots, and only Palawan Island is not covered by a red dot. Meaning, all the provinces and all the regions of the Philippines have been affected by earthquakes in the past and can be affected again. In fact, around 100 damaging earthquakes have occurred in the past 400 years, and some of these earthquakes triggered a tsunami. Around 41 local tsunamis have occurred in the country already, aside from at least 3 events generated from Pacific countries. Why is the Philippines prone to a lot of earthquakes? Simply because we are the only country in the world bounded by tectonic plates or big blocks of rocks that would collide towards the Philippines. For example, on the east, we have the Philippine Sea Plate, allowing movement of rocks beneath the Philippine Sea Plate downward towards the west along the East Luzon and the Philippine trenches. While the Manila Trench, Negros Sulu and Sulu trenches, and even the Cotabato trenches would allow movement of blocks of rocks beneath the West Philippine Sea, Sulu Sea, and Celebes Seas towards the east. So we have now a condition where 2 opposing forces are squeezing the Philippines from both sides. Aside from that, please note that Indonesia is pushing Mindanao on the southern end towards the north. And that is why you can see that in recent years, large earthquake events have happened in Negros Island and Bohol, because this northward movement of Mindanao and the eastward movement, southeastward movement of Panay is causing these islands in between to be squeezed. Hence, we see a lot of limestone or corals lifted up from the ocean floor. And that is why we have a lot of white beaches in these different islands in the Visayas. So the opposing forces, due to the trenches on both sides of the Philippines, would cause different islands of the Philippines to be fractured. And when rocks along these fractures move, they are now considered active faults. And the longest fault that we have is the Philippine Fault Zone from Ilocos Norte to Matid to Davao Oriental. And these segments of the Philippine Fault Zone have triggered major earthquake events. But note that even cities little bit away from the Philippine Fault Zone have their own faults to prepare for. For example, in the Metro Manila area, we have the Valley Fault System. In the Cebu province, we have the Cebu Fault System. And in Davao City, we have the Central Davao Fault System. So aside from the fact that the whole country, aside from Palawan Island, is exposed to large earthquake events, our metro areas are more vulnerable because they have their own nearby earthquake generator. When we prepare for earthquake events, we worry about the multiple hazards that earthquake can be associated with. First of all is we want to avoid where the fault can rupture the surface. But during the earthquake event, we worry of about around 4 to 5 hazards. For example, if the earthquake is on land, there can be a strong ground shaking that can cause collapses of houses and buildings. Soft ground will behave like liquid, there will be liquefaction, and steep slopes can be affected by landslides. It is also possible that during the shaking or immediately after, there can be fire because of various causes like electrical short circuit or toppling of lamps. If the earthquake is near shore or offshore, a tsunami can be generated if the ocean floor vertically moves up or down, or if there's a submarine landslide. So earthquakes would need to be prepared for in a wider scale, just like a tropical cyclone, because of multiple hazards that it would bring. Now, in the following series of slides that I will show you, I would like to emphasize that the point that the whole country, locally or regionally, needs to prepare for their own earthquake scenario, because there are various faults that are present in these different areas. Okay, so from north to south, we can see different areas with maps of different colors. But just to be acquainted with the colors, reddish would be around intensity 7 to 8. These are damaging earthquakes already. And at intensity 8, you cannot stand normally, and you usually tend to fall down. You would have difficulty standing. So we expect significant damage in areas with the color of red and even yellow at intensity 6 if the construction in the area is not so good. So I will show you the different scenarios. It's not all, but I just wanted you to have an imagination that at least maybe aside from Palawan Island, the rest of the country would need to prepare for an intensity 8 earthquake shaking. Okay, so we have the Manila Trends, the Cagayan and Mountain Province faults. We have the faults in Central Luzon, in the Rizal Quezon Province, in Mindoro, and in Bicol, also generating very strong earthquake events. In the Visayas, we can have the West Panay Fault or the Negros Trends, or one of the faults in Cebu or in Leyte that can generate also intensity 8 shaking. In Mindanao, we have the Sulu Trends, the Philippine Fault Zone in the Caraga area, and other faults in the middle or southern end of Mindanao that can cause significant shaking. What is an intensity 8 shaking? An intensity 8 shaking is when people cannot stand anymore, just like what is shown in the CCTV clip in Kobe, Japan. Here, a magnitude 7+ earthquake event caused an intensity 8 shaking. And here you can see people unable to stand normally, so that's why they have to drop and hold on to the table. You can also see the vehicle outside of the building shaking, and things that are not so secured would fall down. It's good that this building did not collapse, but things inside the non-structural parts of the building can still cause injuries to people, and we also need to prepare for all of this. So for safety purposes, the importance for preparing for an earthquake would be location. Second is the quality of materials, the right design, and the right workmanship. And of course, when inside, how prepared you are. Tsunamis are also associated with large earthquake events. And essentially, the whole coastlines of the country are prone to tsunami or can be affected by a tsunami. More prone, however, would be those coastlines that are fronting the big bodies of water, like the Philippine Sea, the West Philippine Sea or South China Sea area, the Sulu Sea, and the Celebes Seas. Why is this so? Because trenches are where large earthquakes are triggered and where vertical movement of the ocean floor can happen. Aside from that, those on the eastern side can be affected by tsunamis coming from other countries. So we have two types of tsunamis: the local or near field tsunami. These are generated by earthquake events just offshore of the country, and the lead time will be very short, 2 to 10 minutes up to around 1 hour, depending on how far the area is from the epicenter. And on the eastern side, the coastlines can be affected by distant or far field tsunami. Generated outside of the Philippines, can have around 1 hour lead time if it's from Taiwan or those in the south of Mindanao, up to 26 hours if it would come from South America. We have prepared tsunami scenarios for the different parts of the Philippines, and these are based on maximum credible earthquake models that are based on historical tsunami-genic earthquake events and the maximum credible earthquake from the different trenches based on the segmentation. So a trench can be subdivided into segments depending on its orientation and whether there's a tear in parts of the trenches. So shown on the right would be the trench segments. Shown in the middle map would be the earthquakes that have caused tsunamis in various parts of the country. And you would note that a lot of tsunami-genic earthquakes have occurred in Mindanao, some in the Visayas, a few in Western Luzon, and many in some parts of Eastern Northern Luzon. So I will show you now the different tsunami scenarios that we have done for some of the segments that that are shown in the map, starting from north, west, down south, and from east, from the north to the south. Okay, for the Manila Trench scenario west of Luzon, we can have this magnitude 8.4 earthquake and also a possible magnitude 8.1 earthquake event. And you would note that in the map, sometimes you might be able to see the numbers there. These are the number of minutes it will take for the tsunami to arrive towards the coastline. And I'm just showing you the maximum height for the models that I'm showing and the fastest arrival time. So in these models, we have the 15.4 meter high tsunami waves, and the earliest wave that will arrive will be around 4 minutes. Further south, in Zambales and in Mindoro, which is critical to Metro Manila, you would note in the left side that it will take more than an hour before the tsunami from the West Philippine Sea would reach political Metro Manila. Okay. The height of the tsunami will be around 15 meters max, and those that are very close to the epicenter will be affected within 4 to 6 minutes. So the closer the shoreline is to the epicenter, the faster the arrival of the tsunami wave. So you would see that if there's an earthquake from the Manila Trench, the western side or coastline of Luzon, including Metro Manila, can be affected, even Mindoro and even Palawan. Now in the Visayas, we have the Negros Trench that can cause tsunami as high as 11 meters, okay? And the arrival time can be 3 meters to the shoreline nearest the epicenter. Now, further south in Sulu Sea, in the Zamboanga Peninsula, Sulu area, we can see that tsunamis can be generated and can cause tsunami heights of around 11 meters and would arrive in 3 minutes. In 1897, magnitude at the 7.5 earthquake event occurred offshore of Zamboanga Peninsula. And this caused a tsunami as high as 6 meters in Zamboanga, Basilan area, and around 2 meters in the Sulu Tawi-Tawi area, 2 meters in eastern Palawan, and this even reached Borneo. Okay, in the Celebesi area, which was the site of the magnitude 8.1 earthquake events, 7.9 was modeled there, we can see that the tsunami would cause around 8 to 13 meters tsunami heights. And the arrival would be around 3 minutes in the model, which was also consistent with the 2 to 5 minutes arrival time during the actual tsunami event in 1976. And note that even the bay in General Santos City and even those in the Davao Gulf can be affected later on by some tsunami waves. Okay. On the eastern side, from the north to south, we have the East Luzon Trough scenario. And this can cause tsunami, which is very unusual because of the configuration of some inlets there. This 21 or 22 meter high wave, it will be not the normal range for this area, but this is the highest maximum. And the arrival time is 3 minutes. In the Bicol, Visayas areas, we can actually look at 10 to 14 meters high tsunami waves with arrival time of 3 minutes in some of the areas very close to the epicenter. Further down south, in the eastern Mindanao area, northeastern Mindanao, for example, we have this high tsunami waves of around 10 to 13 meters in the Samar, Surigao del Norte area. And further south, no, in the Davao Oriental area, we can see 14-meter high tsunami waves that can even reach much later, maybe an hour or 50 minutes in the Davao Gulf area. So ladies and gentlemen, what I've shown you would be the tsunami scenarios that we have prepared, and what one would need at the local level or even at the regional level is to make sure that scenarios are considered when preparing. We cannot generalize our preparedness at the local level, and we need to focus on extreme events, and the preparedness and response should be scenario-based. And I hope that at the regional level, these can be coordinated, because a town or a province can be overwhelmed by these events, just like what happened in Yolanda. Okay, in terms of tsunami exposure for the different regions of the Philippines, we note that NCR would have the highest exposure because of the number of people, but other high exposure to tsunami areas would be regions 4A, region 6, and region 7. And the total population prone or exposed to tsunami would be close to 14 million. Note, however, that a single earthquake or tsunami event will not affect the whole country, but multiple regions. Now, note that when it comes to vulnerability to various hazards, including climate change, urban areas would have the highest exposure and vulnerability to these hazards simply because of the dense population, dense building. People will go to metro areas for livelihood. And then since the land would be quite limited, people tend to stay or construct houses in dangerous grounds. And even the investment and the density of offices or organizations in metro areas can render metro areas very vulnerable, not only physically, but economically or governance-wise to the hazards. For example, in Metro Manila, we have around 26 million people for Metro Manila, Bulacan, Rizal, Cavite, Laguna alone. Around close to 2 million buildings. Metro Manila is the center of governance, business, and finance. And regions 3, 4A, and Metro Manila contribute 63% to our economy. And Metro Manila is the seat of headquarters of our uniformed personnel. So the concentration of almost everything in metro areas render it highly vulnerable to any hazard. In terms of earthquake events, Metro Manila has been historically affected by large earthquake events. One can go to the Roman Catholic Cathedral in Manila, and in the inscription, in terms of its history, it says that part of its structures was partially destroyed by earthquake of 1600, by an earthquake of 1645, and 1863. The 1645 earthquake was an earthquake along the Philippine Fault Zone in Gabaldon, Nueva Ecija, which actually cost 3,000 people dead. So that was the last very large earthquake prior to the 1990 earthquake in the area. There was another earthquake in 1880 in Infanta, which also shook Metro Manila, but I think this did not affect Manila Cathedral. However, other churches were affected by that. And in 1968, August 2, a magnitude 7.3 earthquake centered in Casiguran, Aurora, which is around 220 kilometers away from Metro Manila, caused Ruby Tower in Binondo, Manila to collapse, killing 268 people. Note that for that earthquake, 270 people died. 2 were in Central Luzon, different provinces, but the rest was in one building. Why? Because the vulnerability of that building was very high because of its physical state. Now, for Metro Manila, to develop scenarios, we have studied 18 earthquake scenarios. And we look at 2 scenarios that can cause significant damage or impact to Metro Manila. The first is the Valley Fault System earthquake scenario with a length of 100 kilometers for its western side, the West Valley Fault. If the whole length of the fault will move, it can generate a magnitude 7.2 earthquake. And based on studies by FIVOX and United States Geological Survey, this fault moves every 400 to 600 years, generating large earthquake events. Of course, from time to time it moves. We can record earthquake events in some parts of the Valley Fault, even within this year, but those are not really destructive or not even felt. So 400 to 600 years would be the recurrence interval of the movement of the West Valley Fault. And the last generally strong earthquake event from this fault occurred in the 1600s. So we're very close to the 400-year lower limit of the possible movement of the fault. 7.2 earthquake can cause significant shaking. The other scenario would be magnitude 8 or greater earthquake event from the Manila Trench. Although it is further away from Metro Manila, it is closer to other provinces, and these provinces can be shaken strongly. The strength of shaking from a Manila Trench scenario is lesser than the Valley Fault scenario. So in terms of ground shaking, we look into the Valley Fault scenario as the one that will cause significant damage. However, for the Manila Trench, we also need to worry about its possible tsunami that can affect provinces in Mimaropa, Central Luzon, and even further north and south of the western coast of Luzon and Mindoro and Palawan, but also a tsunami in Metro Manila. Now, in terms of the Valley Fault System, the study made by JICA, MMD, and FIVOX way back in 2004 noted that if the Valley Fault will move, there will be strong shaking of intensity 8 in Metro Manila, okay? And FIVOX looked into the simulation that we have. It can affect Bulacan, parts of Western Rizal, big part of Cavite, Laguna, Northern Batangas, and Southern Pampanga. In Metro Manila alone, we think that around 35 to 38% of residential, mid-rise buildings, and public buildings will suffer slight to heavy damage. Only 14% of 30 to 60-story buildings. Casualties would be around 33,500, and additional death might come from fire or those from severely injured people. This was in 2004. FIVOX combined its human resources in modeling with modeling the possible earthquake event and the ground shaking that can happen with Geoscience Australia. And we developed 2 scenarios. Again, magnitude 7.2 is the worst case scenario, but we also asked ourselves, how about if the magnitude is not 7.2 but much less? What will be the effect? So we looked into the 1658 event, which is like a 6.5 magnitude earthquake scenario. And here in front of you would be the map. Yellow would be again intensity 8, and green will be intensity 7. Note that, of course, if the earthquake is centered in the middle of the West Valley Fault, NCR, Bulacan, Rizal, Cavite, Laguna, and perhaps parts of Batangas can be shaken by intensity 8 earthquake. If it's a 6.5 earthquake, then still Metro Manila will be shaken, parts of Rizal, parts of Laguna and Cavite, and of course Bulacan, but much less in terms of the area. Now, what would then be the impact in terms of casualty and building damage? If we compare the two of the 2 scenarios, obviously, you still have the magnitude 7.2 generating a lot of death, 31,000, very similar statistically to what we have done with the JICA project. But 6.5 will also trigger tens of thousands of deaths. A magnitude 6.5 can cause 23,000 deaths. Why is this so? Well, essentially, this is not only dependent on the magnitude, but the number of people, and most especially the type of housing that we have in Metro Manila, where there are a lot of non-engineered houses and old construction. And so we need to look into the physical vulnerability of these different structures so that we can really decrease the number of death and even injury to those in Metro Manila. Note that in 2017, a magnitude 6.5 earthquake occurred in Ormoc City in Leyte, and only less than 10 people died. So imagine transporting that 6.5 in Metro Manila will cost tens of thousands. Again, because of exposure and vulnerability of people and housing. What other effects do we see as a scenario from Metro Manila? Well, the West Valley Fault transects major roads like C5, Ortigas, and Marcos Highway, even SLEX, and a rail line in northern Metro Manila. And it's very near SLEX interchange of Alabang and Susana. Around 3,000 buildings or houses are exposed to surface faulting, and this would be within the 5 meters on both sides buffer zone. Hence, transport can be affected in some areas. More importantly, during the shaking, soft ground can liquefy. The map on the left would show you the different areas that can be affected by liquefaction and the population at risk to liquefaction, which is quite large. Nonetheless, liquefaction per se will not kill people. The building collapses will do. So we don't estimate the casualty here, but look at the number of buildings exposed to liquefaction, close to 570,000. And the roads can be fissured and would be rendered impassable immediately after the earthquake event. If we can take a snapshot of what can happen in Metro Manila immediately after the earthquake, we can see that it is possible that different areas of Metro Manila can be temporarily isolated due to mobility problems because of damages to bridges across Pasig River and other rivers like Marikina River and other small rivers in the western side of Manila, road damages, building damage, and even fire. And that is why we need to look into isolation as an issue so that we can assign responders to these different groups of isolated areas. In terms of the tsunami scenario, if there's a magnitude 8.3 earthquake event from the Manila Trench, then we think that given the favorable high tide, then the tsunami as high as 6 meters can inundate Metro Manila within 2 to 3 kilometers from the shoreline. The arrival time will be more than an hour, so there is still a lot of time, but 1 hour, although a lot, can be very small if people and the communities and the LGUs don't know what to do and react to a possible tsunami. That should have enough information from those earlier affected provinces or towns if this scenario would happen. Okay. For a tsunami scenario, around 2.4 million people are exposed to this. If we talk about nighttime population, if they are there, it does not mean that they will die. They're just there. They can be affected. But around 300,000 buildings can be exposed. Okay, and there are important government facilities located in the tsunami zone. Now, before I proceed, I would just like to summarize that what I've shown you would be the scenarios that can happen, and the scenarios can give you a better picture of how we will have to prepare and how to respond to these different events. That is why it is important to encourage scenario-based preparedness and response planning so that we can actually appropriately respond to these different extreme events. Turning into another problem, an extreme change globally, we talk about climate change. There is a need to really look into climate change adaptation. This graph would show you a plot of the annual global temperature divided into 2 periods. The first period would show you a more or less variable temperature, but somewhat a horizontal trend. And the second part will be the variable temperature, but with an increasing trend. Now, we are okay with varying temperature because we are able to cope with a specific range of temperature. But if there are temperatures outside of our coping range, that would be what we call temperature that would cause us vulnerability. So for example, if there is El Nino, very hot, We can see drought, changes in the temperature all over the place. But with global warming and with increasing temperature, then the temperature range will exceed the current coping range. So we need to further widen our coping range, and that is what we call adaptation. But if our adaptation is not that much, then we will still become vulnerable if the temperature would further increase in the years to come. That's why it is important to look into how we can adapt to the changing temperature and climate condition globally and in the country. Let me now show you the detected changes in the Philippine climate from historical observations by PAGASA in terms of temperature, rainfall, and tropical cyclones. This would show you the increase in temperature of around 0.68 degrees in the past 65 years, or around 0.1 degrees centigrade every decade. So indeed, global warming or warming is here in the Philippines. And this warming is actually mostly affected by the increase in the warming conditions or the minimum temperature or during the evening, meaning the coldest night is actually increasing in temperature rather than the increase in the maximum temperature during daytime. Okay, so we need to consider that this is indeed happening in the country, and this will continue because of, again, as I mentioned, the natural tendency of the Earth now to be in the global warming phase, plus the greenhouse gas effect because of man's intervention. Now, if you look at what has been observed in the past many years, we can see that there are notable rainfall decrease in these areas colored in circle. In North Luzon, some parts of Mimaropa, Western Visayas, and Western Mindanao in different quarters of the year. But notable rainfall increases also in Central Luzon, including Metro Manila and Eastern Visayas. In terms of tropical cyclones, we note that there is minimal decrease in the number of tropical cyclones entering the Philippine area of responsibility, no? And making landfall over the Philippines, the blue line. Hence, tropical cyclone is slightly decreasing. However, in terms of intensity, there's an increase in number of strong tropical cyclones with maximum wind speeds of greater than 170 kilometers per hour. And note that this would be around signal number 4 and number 5 in terms of the PAGASA wind alert system. So given this observation, where are we heading? We need to look into projected future changes in the Philippine climate based on model simulations, looking into temperature, rainfall, tropical cyclones, and climate extremes. The climate change that is happening now is attributed to the rapid increase in the concentration of greenhouse gases in the atmosphere. And of course, future climate projections are therefore projected based on the different possible scenarios or pathways of greenhouse gases that are influenced by the level of mitigation or the decrease in greenhouse gas emission that humans can implement. Okay? And these scenarios are termed as the representative concentration pathways, or RCPs. Now, there are two scenarios that we need to look into. The moderate emission scenario, where a reduction scenario of greenhouse gases is significant based on mitigation policy implemented, and high emission scenario, where scenarios without additional efforts to constrain emissions would ensue. Okay, so high and moderate emission scenario. What are the projected temperature changes in the Philippines? The red graph there would be the high emission scenario, and the blue line would be the moderate emission scenario. And the table below would show you the temperature changes by the mid-century and last century. For the moderate emission scenario, we expect 0.9 to 1.9 degrees centigrade by the mid-century and 1.3 to 2.5 degrees centigrade in the late century. If we don't control our greenhouse gas emission, it will be very hot. 1.2 to 2.3 degrees centigrade change in the mid-century and 2.5 to 4.1 degrees centigrade in the end of the century. And scientists indicate that 1.5 degrees centigrade of change will already bring us to the tipping point where perhaps the irreversible changes can happen. So we can still fight climate change, but we need to do it fast and as a whole of society globally. In terms of the rainfall projection, the changes will not be even. We have here different conditions to cover different possibilities. We have the wettest possible condition, mid-range condition, and driest possible condition. Again, subdivided into quarters from December to February, March to May, June, August, and September to November. If you look at the mid-range condition, we will see that there will be parts of North and Central Luzon and some parts of Visayas that will have projected increase in rainfall, seasonal rainfall. But a big part of it, from Visayas to Mindanao will have lesser rainfall, seasonal rainfall. Seasonal rainfall would be per quarter like this. In terms of tropical cyclones, models would indicate that the frequency or the number of tropical cyclones would decrease. More models favor decrease rather than no change. But a majority of the models would indicate that there will be a change in tropical cyclone intensity, and this will be more intense. So we need to prepare for more intense tropical cyclones, hence stronger storm surges as well. In terms of the projected changes in terms of temperature, we see here the projected changes in temperature based on the warmest daytime temperature. It will increase by about 1.7 degrees centigrade for a moderate emission scenario, or 3.7 degrees centigrade for a high emission scenario. The graph is interpreted by looking at the baseline from 1986 to 2005, and the projected change in the next 20 years, mid-century and end of the century. And note that the reddening of the different areas, of course, will be more intense for a high emission scenario. Can we withstand such very high change in temperature? For fraction of hot days, if we look at how many hot days will there be in the future, then we will also see that the fraction of hot days will also projected to increase by 50 to 75%. 50% for a moderate emission scenario and 75% for a very high emission scenario. So indeed, we need to be prepared for a hot environment. In terms of rainfall extremes in the Philippines, and this would be very important in terms of floods and landslide events, because if there is an extreme rainfall, then we will have flooding in several areas. Note that currently we look into 100 millimeters of rainfall in a day, and that would be the threshold either for floods or landslide events in the country. So if you look at the left side of the graph, you would see the millimeters. The darker blue it is, then the higher the rainfall. And so you would see an increases in maximum one-day rainfall in many areas of Luzon and in some parts of Mindanao towards the end of the 21st century. Okay. If we now look into 5-day rainfall event, the projections would also point towards increases in the maximum 5-day rainfall over many areas in Luzon and some parts of Mindanao. So if you are able to look into your specific province of interest, like North Luzon and Central Mindanao, I would show you now the areas that are prone to landslides and floods. Here, this is a map of flood in the whole Philippines. Recently, we have the Typhoon Ulysses in the central and northern Luzon and Rolly in Manila. So we have to prepare for flood events, most especially here in this area, as projected by Pag-asa, that more extreme rainfall would be in Luzon and even in central Mindanao. So we can see that in the Cotabato and surrounding area, we have also a flood-prone area. Likewise, we will see a lot of landslides in north and eastern Luzon and even in Mindanao. Now, what would this temperature increase mean? These different changes in temperature would lead us into saying that indeed extreme heat will cause severe heat in many of our populations. We need to look into senior people, those with respiratory problem, those with hypertension. So health effect will happen. We also need to look into the increasing sea level rise of around 0.4 to 0.46 meters with changes in temperature, and higher if it will be hotter. So many of our coastal communities and even many of our cities are situated in the coast, so we will be affected by it. Agriculture, forestry, energy supply can be affected by changes in water distribution. So we need to look into agricultural production. So we have to have agriculture for the future, health for the future, and even power for the future because of these changes. Indeed, our marine production will also be affected because as the ocean is warming up, the water becomes more acidic. So there will be coral bleaching and there will be an effect on marine resources. So what do we need to do? With the availability of climate projection at the local level, we need to have an effective adaptation strategies, which can only be identified through the collaboration between community members, the local and national government units, the academe and field experts, policy advisors, and formulators. And we need to co-develop and co-implement strategy among the various stakeholders that should lead to development of reliable, relevant, and actionable outcomes. And the most practical solution is we need to look into sector-specific adaptation strategies to address the identified future impacts of climate change, targeting specific issues like, for example, agriculture, water management, energy supply, health, the construction industry, and many others would really be a very practical and reasonable approach to avoid being overwhelmed by the so many hazards and scenarios that are related to natural hazards and climate change. So what are the recommendations? We need to have a review and development of hazard and risk-sensitive land use, infrastructure and development plans, considering various natural hazards and climate change. We also need to mainstream risk reduction or climate change adaptation in national and local development plans. Easy to do, but we need to have more studies to guide the local governments and national agencies to do this. Hence, we need to have capacity building for appropriate preparedness and response at various levels, national to local, the private sector or the businesses, and the communities. And these should be based on hazard and risk scenarios and climate projections. We should not prepare for hazards that we don't have a very good scenario. Like for an earthquake in urban area, like the big one or the big earthquake that can happen in Metro Manila, we're fighting like a heavyweight opponent here. So our preparedness should also be heavyweight or super heavyweight and not a lightweight. We need to develop business and service continuity plans in the industry and government sector. And related to this is we need to improve our Philippine Building Code. This needs to change because of the tremendous development in science and the engineering sector. And we need to adapt to these fast-changing results. We need to have continued improvement of monitoring and warning systems, including risk assessment. And more importantly, as I have stated initially, although we have been improving on our science, monitoring, and risk assessment, we have lagged way behind in terms of the reduction of exposure. Still too many people are exposed in many areas, and the vulnerabilities of communities. More importantly, urban areas are very vulnerable to multiple hazards, and we need to strengthen disaster and climate resilience. in many of our metro areas like Metro Manila, Metro Cebu, Davao, Iloilo, and other cities because there is the concentration of physical, social, and economic opportunities. Example of a plan is the Earthquake Resiliency Program for Greater Metro Manila area, where we want to reduce the risk in Metro Manila for earthquakes and other things by making sure that we reduce the population and investment by dispersing investment in other places, establishing other national government centers in a more resilient site, by formulating service continuity plans so that government can still function even after a major event. And that is related to enforcing resilient building standards. We need to enhance resiliency by making sure that we are ready to respond immediately after a major event, by ensuring resiliency of critical infrastructures, ensuring continuous land, air, and sea access to an area after a disaster, ensuring the immediate availability of water, food, shelter, power, medical and health services, communication, and even security, because it will be chaotic, and making sure that we capacitate first responders to an area. The participation of everyone in our society would be very important in increasing the resilience of Greater Metro Manila area and any other areas in the Philippines. There should be multi-level preparation from national government to local government to communities and even at the household levels. We need to be involved. So in conclusion, let me just say that the country is exposed to extreme natural hazards that can cause significant damages and losses of lives and stunt our economic development. Climate change, even epidemics, okay? All areas need to prepare for climate change and natural hazards. And urban areas are highly vulnerable to large-scale events due to concentration of population, buildings, businesses in a small area, and even institutional capacity limitations. We cannot respond to many of these things. Everyone must be involved for us to be able to prepare based on the scenarios of extreme events and be resilient, so that this must involve everyone's participation. A whole of society approach is a must. And you, just like anyone else, would need to be involved. Thank you very much for your attention.
Thank you, Dr. Solidum, for a very informative and relevant discussion, but at the same time, it's also troubling and worrying because of a lot of disasters that somehow we need to prepare upon. We have some questions. First is, does the disaster risk reduction and climate change consider a pandemic such as we are experiencing today a natural hazard also in the future?
Well, essentially, as a government, we need to be looking into multiple hazards, including epidemic. But it should not be addressed singly by a council. No? Different departments should take the lead. But in terms of really assessing the issue, it should be all incorporated. That is why we are advocating for a database that can actually have sharing of critical information like exposure information. So that everyone can use it with the same data set. We can both prepare for these natural hazards and even the pandemic. Note also that some scientists are looking into the role of man's destruction of our environment and biodiversity, yes, where we are actually moving closer to wild animals and and certain diseases being transferred from the animals to people like COVID-19. And that is also would tend to say that we are either partly to blame and also a natural consequence of our destruction of our environment.
Yes, sir. I'm just hoping that this, like in the near future, if we will have pandemics, we will also have scenarios that you provided in different other natural hazards. Another comment is that regarding the disaster imagination that you introduced a while ago, I think personally it's a good thing that we have a concept of disaster imagination. In the field of futures thinking, it's called future simulation. My question would be, uh, uh, disaster imagination is actually being done by the experts, but I believe personally that it would be more helpful if all everyone, even every people or every Filipinos has that concept of disaster imagination, so as um uh, uh they could tend for themselves during disasters. Does the government have, or the DOST have, this program of democratizing this concept of disaster imagination? Because I believe we have NDRRMMC wherein we are doing earthquake simulation every uh,
Yes.
year.
Okay.
But
Yeah.
can we
Um,
do we democratize this concept of disaster imagination as well?
yes. I use the word disaster imagination just to make it popular and easy to understand rather than
Yes, sir.
future simulation.
Yes,
But
sir.
what I presented would be the large-scale simulation of the hazards and the impacts. But we also need to bring this down because
Yes, sir.
for you to convince people that they should act is for them to have their own disaster imagination.
Yes,
So you
sir.
need to bring down the scale of the national scope that I presented or community scope to the individual and family level. And that is why the DOST, through its various agencies like DOST FIVOX, is developing applications that can enable one to know the hazards that can affect the area. We have the Hazard Hunter. In less than 1 minute, just double click or tap the screen of your phone where your house is located or your school is located or whatever, then you will be able to have an assessment of all the hazards in your area. Second, that's only for the safe location or the location assessment. Then the second is you need to look into the assessment of the structure. We just released, of course, this year, uh, the How Safe is My House application, both for Android and iPhone, where one can, if you're not an engineer, you would not know the standards for building construction.
Yes, sir.
Unfortunately, even if you have a PhD, if you don't read on it, you wouldn't know. And
Yes.
what we wanted to do is popularize this assessment at this individual level using tools and gadgets so that they can assess their preparedness by first looking into whether the house will be destroyed by an earthquake or not. And if it's not strong enough, then they can actually further consult other experts like engineers how to strengthen. So that is one. I myself, many years ago, has been planning to develop a self-guided planning tool to assess and prepare for these different hazards. So we hope to do this at the community level, and it's easy for an individual level because you're just looking at your house. So we hope to develop that because we now have many apps where you can actually pull in all the hazards information. Then you add on the structural evaluation of your house. But of course, there are different types of houses. But to answer your question, yes, there are programs. OCD is doing the simulation, but the DOST led it. And for different areas, they're using different earthquake scenarios as provided by FIVOX. It's not the same, although it's just the same drill, but the scenarios are different. It depends on their locality.
Okay, sir. Thank you, sir. Another question is regarding the tsunami simulation. When it comes to earthquake from Manila Trench, what is the effect of geography of the Manila Bay to the nature of the wave of tsunami? Does it amplify or lessen the impact of the tsunami because of the um,
Okay.
geography of the Manila Bay?
Okay. Despite the presence of Corregidor Island, the last bastion during World War II, it will not prevent the tsunami from entering Manila Bay. It will slow down the tsunami. So it will give Metro Manilans a little bit of more than an hour of lead time. The higher tsunami waves will be seen in Bataan, Mindoro, and even Batangas Cavite area higher than Metro Manila. But it will still be significant. Like if the tide is quite high, it will be around 5.5 meters to 6 meters. And it will reverberate, no? So the tsunami, the oscillation of the waves will not end right away because of the bay. It will trap the energy a little bit. So in essence, one cannot say all clear order No, once the tsunami is passed, usually the civil defense or the local government will say, all clear, now you can do the rescue. The oscillation will still be there, but perhaps much smaller.
Okay, sir. Thank you, sir. As a follow-up question to that, we have all the scenarios that the USD had studied in the data. How is this information disseminated to the local communities? I believe, sir, that we have in our local communities the disaster map.
Yes.
Um,
That is why FIVOX, together with other agencies, developed the GeoRIS Philippines platform. GeoRIS Philippines platform is an initiative by DOST, as proposed by FIVOX, to provide everyone, all individuals and the communities, free access to the latest available hazard maps from government organizations, and even those who are doing academic studies. If they want to contribute, then they can do it. Second is we also encourage the local governments and people in the local government to use this so that they can have planning with a better data set at the individual family and community level. The challenge though is one, um, developing the exposure database, meaning being able to describe everything, every house or building, the people, the contents, the social indices, no? So that we can actually have not only physical vulnerability assessment, which we have another software, but also the social vulnerability assessment, so that we can plan better. Now, we're working with other agencies where they can use the platform. Second challenge is they need to convert the action into planning, to plans. That's a challenge, and I think not all local governments have some technical people or even disaster managers to do that. That is why even up to now, although it's not our main job, we are still doing a lot of pilot planning and drills so that local governments can learn from what we do. We have a separate training for physical impact assessment. We have another software that has been going on since 2006. But the real issue for me is converting all these scenarios into plans, contingency plans appropriate to what can happen in their area. That is why my goal is to really develop an application so that the communities can be guided based on the different available information that can be pulled. It's a little bit of a challenge because many of the information would have to come from the local government. But
yes.
developing a planning app can be a very good tool for them.
Yes, sir. Thank you, sir. Another question, sir. You have presented the projected changes in temperature and rainfall. Um, uh, how would the changes affect the livelihood of the people? Because most of in our countries are farmers and the fishermen, and I think the, the 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 changes in the temperature and the rainfall would really affect their livelihood. Is this
Yes.
part of the scenario that is that part of the data that the scenario is looking on?
Yes, the projections made by DOST through Pagasa is available for everyone, especially the government sectors. And essentially, we need to have this agriculture for the future, industry for the future because of these changes in temperature and rainfall distribution and even pattern. And so we have years in advance to do this, but we need to act fast. For example, we have to have more resistant crops for extreme rainfall also, or extreme heat, no? And that can be looked into by the geneticists if they want. So there are many projects already being done on this in other countries, and perhaps we can do this in the country as well. I know that there are things being done, but I'm not privy to those.